Hello, I'm Scott Moore, your host for the SMC Journal Report. That's what you're watching. If you're interested in anything that has to do with performance testing, engineering, monitoring, optimization, anything that has to do with making applications perform better, being more resilient and more efficient, this is the show for you. We're talking about news, events, features, companies, all kinds of stuff here today. And if you like what you see, maybe give me a thumbs up and a like, share, subscribe on YouTube, whatever, so that you let me know I'm headed in the right direction. Now, for our subject today, I know many of you like to talk about artificial intelligence and AI, and you're wondering, where are we at? Because every time I hear the word or the letters AI, I hear a word after that that says hype. Typically there's the word hype in some sentence just further down talking about that, because some people really don't believe, like, we're just at the beginning stages and there's a lot of smoke and mirrors, and I believe that that is the case. However, as I've been doing some of my research and thinking about how it affects the performance engineer, I'm like, well, where are we at there? So just some thoughts about this and a recent report that just came out, and my friends at Tricentis, I feel like, have really dropped a big bomb out there for everybody to see in public. I think you should see this use case. I'm going to show it to you today. Just some really interesting information. So let's just talk in brief about AI. I was having a conversation with a friend of mine in the software testing industry, and he said, you know, when you first say AI, let's say it's to somebody who doesn't have any IT experience. They're not a developer, they're not technical or anything with computers. My dad, right? When these folks think of AI, typically, first thing they come up with is I watched the Terminator. That's where it's all headed. We're all gonna die. They're making Skynet, right? So you get that, but in reality, what is it? So the way he described it, I really like this analogy. What if you lost your keys? Where would you go look for your keys? Well, the first logical place where I typically leave my keys. And if they're not there, then where do I go? Well, the next most logical place where I might leave my keys. Or where did I leave them? I'm backtracking, right? I am subconsciously just creating a rules-based engine on where to go look. And if that doesn't, then this, then that. And I'm developing relationships and mapping that in my brain real time. This is the way he described AI, and I think it's pretty accurate. Those of you who work in AI, maybe you disagree or have additional comments for me, but I think that's a good way for looking at it. And I remember when I saw Vertica come out from HP several years ago at one of the HP conferences, a person described that engine as taking a file cabinet and just dumping all the contents out. Now in that file cabinet you would have, like, say, manila folders with a label on each area and several documents that map to that subject, right? This subject is, you know, auto. The second one is home. The third one is, you know, I don't know, party time. Whatever that subject is, it just gets dumped all on the floor, and then the AI engine is able to start picking that up, and as it's putting it back into the folders, it's looking at everything on there and saying, you know, there's a relationship between home and auto that maybe you know about, and there's maybe some that you don't know about. Here's a weird relationship that you didn't think about how these things are related in some way. Maybe it's parallel or diametrically opposed statistically. And so you get to thinking about that, and you can come up with some interesting outcomes when you start building those kinds of engines. So hopefully I haven't confused you at this point, but when I hear mostly about how in the engineering space, what are we really using AI for, it's mostly for, like, things like preventative maintenance, right? I hear about, like, there's some fans out there that cost a lot of money, and when the ball bearings inside the fan motor get too hot, it just explodes all over, you know, and it costs $30,000 to fix this fan. But if you put a little sensor on there, it can tell you the temperature of this, and when it increases to a certain percentage, hey, you've got like 2 weeks to fix this fan with a $1 ball bearing to replace it and some grease, or you got a $30,000 repair bill. Okay, totally get it. I think that's wonderful. That's probably more in the IoT space. But Getting back to where we live in software testing, where I really can't go any further without talking about my friends at Akamas. So if you go to akamas.io, you'll see this is more of an optimization engine that they've built with AI. And here's a perfect example is trying to tame a Java application. So think of all the settings, all the configuration settings for a JVM and garbage collection and all these things that you would do. You can run into a long period of tuning exercises trying to figure that out. And also, how do you make those settings work while you want to minimize the cost of your cloud bill? You have a limited amount of memory, or you don't want to go over this much CPU utilization over a certain period of time. There's all these kind of things that would take you literally weeks or months to manually run these tests and look at the results as fast as you can run them through. Even through a CI, you still have to make those changes. And that's where Akamas comes in, and this is not a commercial for Akamas, they're not a sponsor, but they go out and the Akamas will run the test, change the settings, run the test, change the settings, and can get you there in a matter of days versus weeks or months. Now, I've actually got experience doing this manually. Back in the day, I remember being at a Microsoft facility just outside of Dallas, Texas, in their Las Colinas lab, and we were doing an experiment on a new Microsoft technology, but it used SQL Server on the back end for the database. And we had a team of probably 8 or 10 people. We're there for 7, 8 days, 16 hours a day, over the weekend, sometimes more than that, eating in the facility, almost sleeping in the facility. And, at the end of 18 hours, how productive really are you? And everybody's just, But I learned so much out of that exercise. And also, we would find things at certain levels of a load test, and it's like, okay, this is where SQL Server is having a problem itself. And they pick up the phone, Microsoft calls their friend upstairs who wrote that piece of the code in SQL Server, comes down and says, oh, yeah, I know what to do. I'll have you a patch in 30 minutes. What? Right? And then we've got our own version customized of SQL Server, at least at that moment, to make this application run as optimized as possible. And of course, they roll that out later in an update, in a feature update, and everybody else gets that ability too. But it's just the learning that comes from that is amazing. But it is a long, drawn-out, tedious process. So if you can use technology like this to speed up that, and it also can work within those limitations that you might have of, hey, we want to optimize how much memory we use because we don't have unlimited resources, and we want to minimize our cost in the cloud because we're cloud native. And this would go for, like, Akamas doesn't just support JVM. It could look at the tuning for Kubernetes containers. It could look for database configuration changes. There's all these different rules, and it's not just Akamas. I'm sure there are other ones. So I just think that's a really interesting thing. Now, here's the big news. All right, Sogeti, part of Capgemini, one of the big consulting companies, just a few weeks ago, it's probably been a couple of weeks now, they released a report called The State of AI Applied to Quality Engineering for the year 2021 and 2022. And I just want to show you this. It's you can download this as a PDF. I don't think you have to register to read it because you can read it online. But just some highlights here. Here's something very interesting where we're trying to reduce the amount of time that it takes to get the engineering done. And this applies to all kinds of engineering and quality, functional security, all these things. But I'm just going to focus on performance right now. But just take a look. We are continuing to have higher complexity and rate of change. You hear that all the time in a lot of these marketing presentations, but it is true. And there's all this disruption that's going on, and we're having to pivot so fast that we need AI to help us get there faster. And that's what a lot of the use cases in this report talk about. Something interesting about this, when I first saw it, it takes it chapter by chapter. Look at chapter 6. This addresses the role of AI in performance engineering. Okay, cool. Well, that's the chapter I want to read first, and then I'll come back and read the rest of it. Also, look at about the report. Who was involved in this report? You have Dynatrace, Eggplant, which makes Eggplant functional with an AI product built into that, and also Eggplant Performance. Micro Focus, so you've got LoadRunner represented there. NeoLoad, which is part of Tricentis now, so NeoLoad is represented. and Tricentis themselves, who have Flood, but also have some AI components in some of their other products as well. So there's AppVance is another one that I recognize in there that talks about performance a lot. So there was a lot of contribution on the performance side here. So it's worth your time to check this report out. I'll share the URL in the YouTube comments and the show notes on smcjournal.com, so don't worry about that. But I thought you'd be interested in seeing that. Now as I started looking through this report, there's a use case there about how Neotis, as part of Tricentis, and how these companies, now Tricentis has acquired Neotis. They're one company now. So you've got NeoLoad and Flood and the other products of Tricentis, and these teams are all working together, and they're starting to collaborate, and they have been collaborating for several months now. I saw this in the report, and I just have to share. I think it's a bombshell. Here is a use case for how you can use AI in performance engineering. Representing performance tests based on real-life production traffic. So look at this. AI is unquestionably a technology that can assist us in performance engineering, and in this chapter we will examine how to leverage AI to assess production traffic as a data source. So looking at your production traffic using an AI engine to then tell your pre-production crew, this is the model that you should create that will mimic production as closely as possible, so they don't have to do all this research to find out how long it would take. So they're basically saying we want to cut the time, I think they say in half, to do this. This is a project by Neotis called Project Rachel. It is not out right now, and this is in the report. This is not like private information that I got. This is out there on the web. Tricentis NeoLoad has developed a prototype solution. It is in a prototype stage called Rachel that we are evaluating with various enterprises that it can leverage AI to assess production traffic as a data source, detect different population and their curves, pacing, think times, like how real users are actually doing stuff in production. Feed that information back to the performance testing group, and then reduce the time that it takes for them to create that model. Now we know what to script, we know how to set up our test scenarios, and we know exactly that it's going to look as close to production as possible. So what's also interesting, if you look down here, they actually show you what Rachel looks like under the hood. So building out Rachel, they wanted the solution to be able to deliver the crucial definitions, elements, all the things you need to model this thing in real life. The load testing scenarios, population, think time, pacing, load policies, the curves that it takes if you wanted to mimic a peak hour or a peak day. So they're gathering information about stuff that the HTTP protocol provides you, mostly in header information, the host name, ports, etc. And then they actually show you how Rachel is put together. So you've got a recorder that is like a reverse proxy that's gathering this information, sending it to Rachel, which is a traffic filtering, it makes it anonymous, stores and creates analysis from this AI engine, and then sends it back to the person who I guess is going to do the performance testing. And this is something that you can probably look for in the near future in NeoLoad. Another point I want to make in here, which you can read this report for yourself, is who wrote the report. Patrice Albert is a product manager for NeoLoad. He works in the R&D side of this. He's the one that's helping to create this and build this. So this is not hearsay about the vendor. This is the vendor themselves telling us this information. So this is them working not only with the performance team building NeoLoad, but they're working with the functional teams and the other teams, the AI teams that are within Tricentis, building something new, and they're sharing this with you to let you know. They're trying to make your life easier as a performance tester to just make things quicker for you. So here's your production information you need to know. Build tests that match this, and then you should have a pretty decent comparison. You don't have to guess and do all these interviews with business analysts and QA people and look at logs and all these things. It'll do that for you, I guess. So this is something that, you know, is kind of revealing about the product roadmap for NeoLoad as well. Now, we don't know when this is going to come out and what way it will come out. But it's just something to be watching for. And I just thought, you know, for them to put that out there in this public Sogeti report, you know, that's pretty brave. That's pretty bold of them to share that information. But I think it's because they're wanting this to be better for the community as a whole. And they're speaking to you, performance community. I would hope that you would respond to that and say, hey, you know, maybe this is a great idea, or hey, I've got some ideas to even make this better and help contribute to that. That's what I'd really like to see kind of come out of this. So what do you think about this report? Read it and let's talk about this. I want to make this kind of an interactive conversation. So you can always reach me at my website, scottmoore.consulting. I'm available on Twitter at LoadTester. That's my handle. There's the URL, how you can reach me on LinkedIn, and I am active on that. And feel free when you see post or you want to send me a private message, that's fine too. So we're working on ways to make it even easier to reach me and talk through forums. I do have a Slack workspace. It's invite only, but if you'll contact me, I can probably hook you up with that. And you can reach me at that email down there, help@scottmoore.consulting. So tell me, what do you think about this? What do you think about the show? And let's just keep the conversation rolling. I just think it's a pretty cool thing. Where do you think we can also use AI in performance engineering as well? I'm interested to hear your thoughts about that. So I'd also like to thank our sponsors for this show, which are Haymaker Coffee Company. I have a special code just for you called PERF10, and if you use that code on their website at haymakercoffeeco.com, you will get 10% off this coffee. More news of how we're working with Haymaker Coffee Company coming soon. I'd also like to thank Bright Payment Solutions for their support of this show. If you are a company that is taking payments and through credit cards and you're using something like Stripe or PayPal or something like that, you need to check out brightps.com, contact them and say, hey, how can you reduce this overhead and these fees that add up over time, especially if you're like a restaurant or you have connections in your own network that could probably use this. Point them there and tell them that Scott Moore sent you to them so that they can save money on their overhead and their fee for how they process these credit card payments. So, appreciate that and appreciate your sponsorship of this show. Thank you for watching the SMC Journal. I'm Scott Moore, and I'll see you next time.